Welcome to this video. This is Dr. Kiran Derle, and in this video we'll see the concept of LCM and HCF, right? The model of HCF and LCM, the most commonly asked models of LCM and HCF as far as specific topic is concerned, and some important formulas at the end. Some important formulas related to LCM and HCF at the end, right? So let's get started. Okay, so we get these kind of questions, right? So this is model 1, we can say, or type 1 questions on LCM. If R is the remainder in each case when n is divided by xyz, these are divisors, right? So this is your remainder, right? N is the number. Then the general format of the number n is equal to k into, where k is any natural number, right? We'll understand why importance of k here. LCM of the divisors plus the remainder, that value of remainder, right? So R is the remainder in each case. So let us understand this model with this example. When n is divided by 10, 12 and 15, so these are divisors of n, right? So n is being divided by these divisors. The remainder is 3 in each case. So in each case we are getting 3 as the remainder. Find the smallest value of n. So when you divide some specific value of n by 10, you get the remainder 3. When you divide by 12, you still get the remainder 3. You divided by 15, you still get the remainder as 3, right? This is what the question is. So this n can be found out by k into what is LCM of xyz, LCM of 10, 12 and 15. Irrespective of number, see, you may have 2 divisors, 3, 4, 5, 6, whatever divisor. This format will not get changed. This is constant, right? So when n is divided by this, remainder is 3 in each case. So we are getting 3 as the remainder. Same remainder we are getting in each case. You can say this case is of getting same remainder in each case. Right? So k into what is LCM of these three? Larger number is 15. 15 is divisible by this? No. So next number is 30. Divisible by this? Yes, but not by this. So cannot be the LCM of all the three. So 45, not by this. 60, yes, by this and has to be by this. I hope this is good. So 60 is the LCM of all the three. So k into 60 plus r is what? 3, right? So what is the question now? What will be the value of k? The question is find the smallest 2-digit value, you can say, smallest 2-digit value of n. So if you want smallest 2-digit value, the value of k should be 1. Right? According to the question, we have to change this. So the number becomes 63. So 63 is such a number, when you divide this by 10, the remainder is 3. When you divide by 12, remainder is 3. When you divide by 15, remainder is still 3. I hope you are getting the basic understanding of this question. So when you get same remainder in each case, the format of the number is like this, right? So k into 60. So if the question would have been like this, find the least 3-digit value of n, if the number would have been like this. So k into 60 plus 3, right? So we want least 3-digit number. So the value of k would have been 2 into 60 plus 3, that is 123. 123 is least such a number. When divided by 10, remainder is 3. When divided by 12, remainder is 3. When divided by 15, remainder is 3 in each case. I hope you have got this model, right? I hope this is clear. Fine. Okay, so this is next model, right? If ABC are remainders when n is divided by xyz, right? So this number is divided by these divisors. These are the divisors. These are the divisors, right? Respectively, give them the respect. And x minus a, this divisor minus a, right, that is remainder. Divisor minus remainder, this divisor minus this remainder, this divisor minus this remainder, the differences are equal. The difference between divisor and remainder is same, that is equal. Then n can be written as, this n can be written as k into LCM, this minus r. Here only change is minus r, only change is minus r. Now what does this mean? Let us try to understand with the given question. If n is divided by 12, 16 and 24, the remainders are 8, 12 and 20 respectively. So some value of n when divided by 12, the remainder is 8. 12, the remainder is 8. What is difference? 4. You can see the 4. 16, when divided by 16, remainder is 4. The difference between divisor and remainder is 4. When divided by 24, right, the remainder is 20. Still the difference is 4. So we are getting the constant difference. We are getting the constant difference. This is equal. This is equal. 12 minus 8 is equal to 16 minus 12 is equal to 24 minus 20. I hope this is clear. So whenever the differences are equal, the format of n would go like this. LCM of 12, 16, 24 into k, right, into k minus r, right? R is the difference, common difference, right? So LCM of these three. Larger number is 24. 24 is divisible by this but not by this, so it cannot be the LCM of all the three. 48, yes, 48 is has to be divisible by this. It is divisible by this. It is divisible by this. So 48 is the LCM. 48 into k minus r, right? So the least value will be this. Least value will be this 48. 48 minus the common difference is 4, that is 44. That is 44. I hope you are getting this point. Now what will be least 3-digit value? What will be least 3-digit value of n? What could be the answer? What could be the answer? So the value of k has to be 3. It cannot be 2. Otherwise this will become like this, minus 4, right? So this will again a 2-digit number, I guess. Yes, 96 minus 4, 92. So k's value should be 3. So 48 minus 4, this is least 3-digit value of n, right? When divided by 12, remainder is 8. 16, remainder is 12, and divided by 24, remainder would be 20. I hope this is clear. I hope this is clear. Okay, so important formula, the product of two numbers is equal to the product of LCM and HCF of the two given numbers. So what does this mean? Let A, B are two numbers. These are two numbers, and H is their HCF of the two numbers. So A into B is equal to LCM of AB into HCF of AB. This is a formula, right? We'll understand. We have good number of questions on this formula, right, in question answer video. So for now you can just see the two numbers, product of two numbers is equal to LCM of two numbers into HCF of two numbers. That's it for now. You have to understand, right? We'll solve examples, good number of examples on this. Fine. So LCM of fractions is equal to LCM of numerators upon HCF of denominators. For example, let's take this 3 upon let's say 12, 3 upon 12. Let's take it as 14, and let's take this as 9 upon 20. 22, 9 upon 22, 5. Okay, so what is LCM of these fractions? So LCM of numerators. What is LCM of numerators? Greater number is 9. 9 is divisible by this. Yes, so LCM is 9. LCM of numerator is 9. HCF of denominators. HCF of denominators. This is 2 into 7. This is 2 into 7, right? This is 2 into 11. 2 into 11. So only common factor is 2. So HCF is 2. 9 by 2 is the LCM of these given fractions, these two fractions, right? HCF of the fractions. Let's say we take two examples. Let's take 12 upon say 25, and the other one being 18 upon, let's say, 35, right? These are two fractions. So HCF of fraction. What is HCF of these two fractions? HCF of numerators. HCF of numerators. This is nothing but 2 square into 3, and this is 2 into 3 square. 2 into 3 square. So whenever we calculate HCF, we take lowest power of common factor. Lowest is 2 into, this is also common, but the lowest is 3 raised to 1. 3 raised to 1. So 2 into 3, 6 is the HCF. So HCF of numerators is 6, right? HCF of numerators is 6. I hope you are getting this point. Now LCM of fractions. This is 5 into 5. This is 5 into 7, right? So whenever you calculate LCM, take the highest power of common factor, that is 1 only, and rest uncommon factors. This is 5 into 5, that is, sorry, 5 square, right? 5 square. So highest power of common factor is 5 square into uncommon also, that is 7. So 25 into 7, 175. 175. So LCM is 175. This is our HCF of these given fractions. I hope you are getting this point, right? So hope this is pretty much clear to you now, right? So thank you so much for watching this.